Welcome to this video on using resources. Everything we use comes from the Earth, but not all of it will last forever. We'll be looking at resources and sustainability in this video. Chapter 1 covers the Earth's resources. We'll explore where our materials originate and consider how long they might last. Earth's resources can be explained in three main categories. Natural resources include things like rocks, minerals, water, and living organisms. Synthetic resources are man-made, such as plastics, alloys, and ceramics. Agricultural resources are grown by humans, for example, food, timber, and cotton. Finite resources are those that cannot be replaced once used up. They took millions of years to form, and once gone, they are gone for good. Examples include fossil fuels like coal, oil, and natural gas, metal ores such as iron, copper, and gold, and minerals like limestone, salt, and sand. Renewable resources are naturally replenished, provided we do not overuse them. Examples are solar energy, replenished daily by sunlight. Timber regrows if forests are managed. Wind power is continuously available energy. Sustainable development is about meeting the needs of today without compromising the ability of future generations to meet their own needs. We can achieve this by using less to reduce demand on finite resources, recycling more to recover extracted materials, and switching energy sources to renewables over fossil fuels. Chapter 2 focuses on water. We'll trace the journey of water from rainfall to your tap, and also cover how we treat wastewater. Potable water is safe to drink, but not the same as pure water. It must have low dissolved solids, acceptable mineral levels, and no harmful microbes, meaning bacteria and viruses must be removed. The fresh water source can be rivers, lakes, groundwater, or reservoirs. Remember, pure water contains nothing dissolved, while potable water contains safe levels of dissolved substances. The process for producing potable water includes three main steps. First is sedimentation, where particles settle out of the water. Then, filtration removes remaining solids using sand and gravel. Finally, chlorination adds chlorine to kill microbes. This makes fresh water safe to drink. Wastewater treatment involves 4 steps. Screening removes large solids with mesh screens. Sedimentation allows suspended solids to settle as sludge. Biological treatment uses bacteria to digest organic material. Finally, sludge digestion uses anaerobic bacteria to produce biogas. Desalination removes salt from seawater to produce potable water, which is crucial in areas with water scarcity. Both distillation and reverse osmosis are used, but they require large amounts of energy, making them costly and currently unsustainable at scale. The required practical for water treatment involves 4 steps: setup, filter, add bleach for sterilization, and then test for clarity and microbes. Remember, the water produced is for demonstration only and is not safe to drink. Chapter 3 covers metal extraction and new approaches that are kinder to the environment. Alternative methods are needed because traditional mining is expensive, damaging, and high-grade ores are depleting. The solution is phytomining and bioleaching, which can extract metals from low-grade ores. Phytomining uses plants to absorb metal compounds, which are then burned to extract the metal from the ash. Bioleaching uses bacteria to break down low-grade ores, producing a leachate for copper extraction. Both methods have a lower environmental impact compared to traditional mining. Chapter 4 introduces the life cycle assessment, a tool for measuring a product's impact from its creation until its disposal. Life cycle assessment, or LCA, analyzes a product's environmental impact across all stages of its life. These stages are extracting raw materials, manufacturing, using the product, and finally, disposal or recycling. An LCA measures energy use, water consumption, CO2 and greenhouse gas emissions, waste produced, and impact on ecosystems. Remember that LCAs can be selective or biased, so always evaluate them critically. Comparing plastic and paper bags shows that neither is perfect. Plastic uses finite raw materials but less manufacturing energy and water. Paper uses renewable raw materials but more energy and water. LCA helps us weigh the full picture, not just one factor. Chapter 5 focuses on the 3 R's of sustainable living: reduce, reuse, recycle. The 3 R's are reduce, reuse, and recycle. Reducing is the most effective option, meaning using fewer resources. Reusing extends an item's lifetime. Recycling processes materials into new products. Remember, reduce is the most preferred option. Recycling metals offer significant benefits, such as 95% energy saved for aluminium and 70% for steel compared to extraction from ore. It also conserves finite metal ores, reduces mining damage and CO2 emissions, and decreases landfill waste. We can reduce resource use by using less energy through LED bulbs and insulation. Choose reusables like bottles and bags. Opt for greener travel like walking or cycling. Reduce food waste by planning meals and composting. Chapter 6 will cover corrosion, explaining why metals degrade and how we can prevent it. Corrosion is the degradation of metals by reaction with the environment. Rusting, specifically for iron, requires both oxygen and water to form hydrated iron 3 oxide. The chemical equation is shown on the slide. An experiment proves that both air, oxygen, and water are required for rusting. Iron nails exposed only to dry air, only to boiled water, do not rust. Rust only forms when the iron is exposed to both air and water. Corrosion can be prevented using several methods. These include applying paint or a coating as a barrier, galvanizing with zinc, electroplating for a protective layer, or using sacrificial protection with a more reactive metal. Sacrificial protection works because a more reactive metal, like zinc, corrodes preferentially instead of the iron. This protects structures like ship hulls even if the coating is scratched. Chapter 7 is about alloys and why mixing metals makes them stronger than their pure forms. An alloy is a mixture of two or more elements, with at least one being a metal. Common examples include steel, which is iron and carbon, stainless steel with chromium and nickel for corrosion resistance, bronze, and brass. Alloys are harder than pure metals because the different-sized atoms disrupt the regular layer structure. This prevents the layers from easily sliding over each other, making the material harder and stronger. Chapter 8 explores ceramics, hard, heat-resistant, and brittle materials that are central to many ancient and modern applications. Ceramics are non-metallic solids made from inorganic materials and hardened by high temperatures. Their key properties include hardness, brittleness, high melting points, electrical insulation, and chemical unreactivity. Clay ceramics, like bricks and glass, are common examples. Chapter 9 covers polymers, the foundational materials for everything from natural rubber to synthetic plastics. Polymers are long-chain molecules formed from repeating monomer units. They can be natural, such as silk and DNA, or synthetic, including materials like polythene, nylon, and Teflon. Polymers are classified into two types. Thermosoftening polymers soften on heating due to weak forces between chains, allowing them to be remolded. Thermosetting polymers have strong cross-links, making them permanently hard and unable to be remelted. Chapter 10 delves into composite materials, which combine different materials to achieve superior properties. Composites consist of a matrix, the surrounding material, and a reinforcement, such as fibers or particles. Examples include carbon fiber reinforced polymer, glass reinforced plastic, and concrete. Composites offer the best of both worlds, achieving properties single materials cannot. They are often light yet strong, like CFRP used in aircraft, and allow for flexible design through material selection. The table on the slide outlines common examples and their uses. Chapter 11 provides essential GCSE exam tips and smart strategies to maximize your marks. To tackle the exam, first read the question carefully and identify the command word. Second, use key scientific terminology precisely. Third, always show you're working for calculations, as this can earn you method marks. It is crucial to understand the difference between command words. Describe means stating what happens. Explain requires providing a reason. Evaluate demands advantages, disadvantages, and a conclusion. Compare requires similarities and differences. Suggest means applying knowledge to new situations. And calculate means showing full working with units. Avoid common exam mistakes. Remember, rusting needs both oxygen and water. Potable water is safe to drink, but still contains dissolved salts, unlike pure water. Distinguish between thermosoftening and thermosetting plastics. Finally, always mention that life cycle assessments can be biased. For 6-mark evaluate questions, ensure your answer has structure, present advantages, then disadvantages, and always finish with a justified conclusion. Here is a quickfire checklist covering the main topics. Review water treatment, metal extraction, life cycle assessments, corrosion prevention, and the different material types and how their structure relates to their properties.